Welcome to this beginner video where we go through the basics of how to set up your files and drawings. Many of our customers are beginners in CNC and the software required to build the files. We also have users who do not know the difference between vectors and bitmap images. This guide will go through some of this. You must have 2 to 3 different softwares when working with a CNC. You need a drawing, CAM, and a control software. Let's start with the drawing software. You can draw your own objects or import ready-made vector files that you can buy or find for free on the internet. You can draw in any software you prefer, as long as you can save it as a vector file instead of a bitmap. So what is the difference between a vector image and a bitmap image? A bitmap image uses pixels to represent images, while the vector graphics use basic geometric shapes to represent images. In vector format, the picture quality remains as it is regardless of the size, while a bitmap image gets distorted the bigger the image gets. Here you can see the same picture, but in different formats. The above image is a bitmap image, while the lower one is a vector image. If I zoom in, you will see a clear difference in the quality of the 2 images. Since we want the best result when we cut with a CNC machine, it is vector files we want to work with. The most used vector file extensions, or file types, are .dxf, SVG, PDF, EPS, CDR, and AI. Use these extensions when searching or saving a vector file. There are a variety of drawing software, both free and paid versions. Search for vector drawing software. The second program we need is a CAM software. With a CAM software, we will tell the CNC machine how to cut the file. There are various CAM softwares on the market, both free and paid versions. We recommend and include Vectric's CAM software with our machines. But before we look at the CAM software, we are going to go through different ways to cut with a CNC machine. What is the difference between 2D, 2.5D, and 3D modeling? The video in the background is cutting in 2D. 2 dimensions, 2D, means that you are cutting out a part with features that are all at the same depth. 2.5D means you are cutting a part that has multiple flat features at varying depths. Most simple CAM softwares can handle 2.5D. Working in 3 dimensions, 3D, means that you can control at least 3 axes simultaneously. 3D contouring can then be accomplished by creating curves that use all 3 axes at once. You will most often need a full CAM program to create G-code files capable of performing 3D contouring. Working with 3D files is complicated and requires software that can handle 3D. The file format for 3D files is .stl. Let us take a look at the CAM software Vcarve Cut 2D that we include with our machines. When you start Vcarve for the first time, you need to set it up before you begin. This version of Vcarve only allows you to work with a 600 x 600 mm table. We will set up Vcarve for Mach 3 control software. Choose the post-processor that suits your machine. Select Mach 2/3 arcs as post-processor. Press Apply, then OK. Let's look at some basic functions. Create a new file and set the size and thickness of the piece you are cutting. With Vcarve you can both draw and import your drawings, which means that you can usually manage with only this software. Let's draw a square and a circle. We will cut the circle from the inside and the square from the outside. There are many different tools you can use to draw your parts. When we are done, we will give the circle and the square instructions on how to cut them in the best way. Open the menu on the right and pin it so that it stays open. Click on the first icon, Profile Toolpath. Since the material is 12 mm, we will set the cut depth to 12.5. We want to be sure to cut through. Click on the Select Tool button. There is a lot of tools to choose from, but we will make our own metric tools. To create your own tools, you can choose any tool and duplicate it. Select a tool and press the duplicate button. Let's pause here and talk a little about the tools. We will use a 4 mm 2-flute end mill to cut out our part. If you look at the menu on the left, you will see that we have created 2 different end mills that are 4 mm in diameter. As you can see, we have named them hole and part. The end mills are identical except for the speed. It is a good routine to always create 2 of the same end mills at different speeds. When cutting small parts, the speed should be low and for large parts high. If you cut small parts such as holes at high speed, the result can be bad. It is better to slow down when cutting small details. That's why we will make 2 different 4 mm end mills. If you use a 4 mm end mill with 2 flutes, you can fill in the same values as in this guide. Select millimeter per minute and set the value to 1500 millimeters per minute, which is suitable for small holes. Make another tool with the same settings and name it part, but set the speed to 3500 millimeters per minute. Now, we have 2 similar tools, but with different speeds. Choose the tool we named hole. As you can see, it takes 4 rounds to cut the hole. Select inside/left. Always add tabs on the parts you cut. Without tabs, the end mill can get stuck and damage the part you are working on. Vcarve can add tabs automatically. You can also add or remove tabs manually. It is a good idea to add ramps, so that the end mill goes down with an angle for cleaner cuts. Click Calculate to save the settings. Hold down the Control key on the keyboard at the same time to avoid the animation that would otherwise appear. Vcarve will warn you that the cut will be deeper than the material. Press OK. If you want to preview the toolpath, you can click the Preview button. If everything looks okay, you can go ahead and create a toolpath for the square. Use the same settings. The only difference is that we will choose the tool part, and the square will be cut from the outside. The part is ready. You can save the tool paths and run it in Mach 3 or any other CNC control software. Since we use the same diameter of the end mill, we can save it on the same file. If the diameter of the tool is different, it will be saved to multiple files, and you will need to do a tool change while cutting. Choose Mach 2/3 as post-processor. Let's try one more thing. Create a new page in the same way as last time. This time we are going to import a file and create a quick engraving tool path. If you like this file, you can Google azteccalendar.dxf, and it should come up among the first results. Vcarve makes it easy to engrave complicated vectors, like these. Just select your vector and click Quick Engrave. We will use a 60-degree V-bit tool to engrave this calendar. You can use the default settings, or change them to better suit your machine. We will set the depth to 4 mm and then press Calculate. As you can see, Vcarve did everything for us. Click the preview button to see an animation of the result. You can experiment with different depths. Try 3 mm instead of 4, and so on. Save the file and run it in Mach 3 or any other control software. We hope this video will help you on your way to more advanced carvings. Visit Vectric's own website for more videos. Thank you for watching.